Hello and welcome to Distance and Midpoint, our last section in this unit for Chapter 1, Tools of Geometry. If you want to go ahead and get this down, you can. Pause the video. Same thing goes for the title on our actual page. This is my page 10, so go ahead and grab that title really quickly. And let's jump into it. Distance. We'll start off there. Distance. Let's get that out of there. Distance. And I'm going to put in terms of a number line. So I'm going to put number line. Number line is the absolute value. So by definition, it is the absolute value of the difference between two coordinates. Of the difference means subtraction, difference between two coordinates. So let's draw a quick example of this. Let's draw a number line. This is best, an example of this is if you and a friend live on the same street as each other, and let's say this is point, so let's actually put a whole bunch of dashes here, like a true number line. Let's say this is where you live, point A, your friend lives over here at point B. Let's say 0 is kind of right there in the middle, and we could see that A is at 1, 2, 3, 4, -4, because 4 to the left. B is at 1, 2, 3, 4, 5. This is 5. What is the distance between them? So we could take that, and since it's absolute value, we could say there's a nice convenient equation. AB, the distance from the segment length, or the distance between them, is equal to the absolute value from those two vertical bars of, we could do the left point minus the right point. So we could do -4 minus 5. Or we could even do the opposite. But let's do this one first. -4 minus 5, this turns into a -9. Absolute value of a -9 is a +9. So that distance is, for instance, let's say like 4 blocks. If you lived on the same street, 4 blocks away to the center, 5 blocks to the right, 9 total blocks. That's the idea. Okay, we could even do the inverse of this. I'm going to do this in pink. You don't have to copy this down. But if I have, for instance, AB is equal to the absolute value of, instead, we're going to start from your friend's house, you go to yours. That distance should still be positive, because distance is always positive. 5 minus, and this is important, that's a -4. Two negatives turn into the positive. Absolute value of a 9 is still 9, and we get the same answer. Okay, so you absolutely can do that as well. Now, distance in the xy plane is different, okay? And that's where we actually bring in the Pythagorean theorem. Because if you think of the xy plane, you don't, or if you think of this in real world context, you don't always live on the same street as your friend. Your friend could live, 5 streets over, five streets down, and then 4 streets over, okay? It changes. So we have a different formula for that, and that pretty much stems from the Pythagorean theorem. And if you, let me redraw this in pink, that distance would be the shortest distance from your house to your friend's house. So that's where the Pythagorean theorem kicks in, and we only use the Pythagorean theorem for right triangles. So the Pythagorean theorem is hopefully a recall from elementary geometry. Pythagorean theorem. We're going to be using this a lot this year. And hopefully you know that it is a squared plus b squared is equal to c squared, where c is the hypotenuse. Hypotenuse is the longest side of a triangle. This is your longest side, okay, in a triangle. So if we have, for instance, this triangle here, okay, let's also put a note here. This is a star only for right triangles. That means we have a right angle in the triangle. I'm going to put a right angle right there, the square. And if I said, for instance, this has a length of 3, this has a length of 4, we could actually solve for this length using the Pythagorean theorem. In a triangle, a right triangle, the opposite side of the right angle is always the c value. Okay, so we could do the work here really quick. We could call this A, we could call this B, it doesn't quite matter. the sides are interchangeable. So we have 3 squared plus 4 squared is equal to c squared. 3 squared is 9, 4 squared is 16 is equal to c squared. 9 plus 16 is 25. And we have to square root both sides to get the c by itself. Now this is the tricky part. Anytime you square root in an equation, you should have technically a plus minus, okay? Or actually on the right side, on the left side, plus minus. Square root of 25 is 5. So that means this distance is 5 or negative 5. But in geometry, distance cannot be negative. So we actually eliminate the negative. This only happens when we're talking about lengths or measures. So keep that in mind, okay? How does this relate to the distance in the coordinate plane is on the distance formula, okay? The distance formula is as follows. The distance formula, this is for the xy plane. And this is used given 2 points. Given 2 points, x1, y1, and x2, y2. That just means, first set of coordinates is the 1s, second set of coordinates is the 2s. We have this formula to solve. Distance is equal to the square root of, in parentheses, x1 minus x2 plus, quantity squared, don't forget that, plus y1 minus y2 quantity squared. Now, if you actually look this up online, these numbers might be switched. The 2 might come first. You're going to notice that if the 2's come first, it's going to come first in both sets. Honestly, it doesn't quite matter as long as the numbers coordinate properly, meaning the first numbers are 1s or the first numbers are 2s, okay? And that's how this is the distance formula. How does this look like the Pythagorean theorem, or the one that we have above? Well, if I, for instance, got rid of the square root by squaring both sides, it would look like this. D squared is equal to x1 minus, I should do this in pink, minus x2 squared plus y1 minus y2 squared. And doesn't this resemble c squared plus a squared? C squared is equal to a squared plus b squared. All of this is a, all of this is b. So they are very much related to each other. If you remember the Pythagorean theorem, you should be able to piece this together as well, okay? All right. Last but not least, we have the midpoint formula. Midpoint. Midpoint formula is actually, it's exactly what it sounds like. It's used to solve for a midpoint given 2 points, or even solve for an endpoint given the midpoint and given one of the endpoints. So if we have, for instance, a diagram, let's draw a quick sketch. And if I said, for instance, we have 1 here, 1, 2, let's call this -1, 2, and then we have another distance here. Let's call this 1, 2, 3. Bring 2 more up. These are the points. This is 3, 4, 3 to the right, 4 up. What is this distance from point A to point B? Okay, and what's the midpoint? Well, we could probably guess around here. This looks like it's about 1, 3. But we could actually use the midpoint formula, which is midpoint is equal to the sum of the x's, x1 plus x2, all over 2. Oops, this parenthesis is not supposed to be there. Comma, oops, sorry, that's not supposed to be there. y1 plus y2. Okay, this is going to turn out to be an xy coordinate, just like how I have it here. It turns into an xy, it turns into actual coordinate. So in this particular case, let's just do this really quickly. Let's call this x1, y1, x2, y2, and we could actually solve for it. x1 is -1 plus 1 for 3, all over 2, comma, y1 is 2 plus y2 is 4. Divide this by 2, and we can solve. The midpoint then is equal to negative 1 plus 3 is 2, plus a 2, 1. 2 plus 4, 6. Divide by 2, 3. 1 comma 3. And our prediction was correct. Now, I don't want you to predict it. I want you to do the actual math for it, because this is definitive. This is for sure. Okay? We'll get more practice with that and the distance formula in class. If you do have any questions, please let me know, and I'll see you in the next one. Bye.